Hello and welcome to the MES Interface Startup video. This video has 5 sections. The first section is a general introduction. In the second section, we'll introduce an application scenario that will be used in sections 3 and 4 to start up and configure the server and MES Interface module. And in the last section, we'll be showing how you can confirm your server and MES Interface module are working properly. To start off with, in this section, we'll talk about the high-level benefits and an example of how Mitsubishi Electric's MES Interface module can be used to connect our PLCs to databases without a computer and collect data from the production site and IT layer. Quick note, this video was created based on the operation example in the MES Interface module's user's manual. For additional details, please refer to this document. To start with, let's look at what the benefits are of using the MES Interface module over a traditional solution. Number 1, a gateway computer is not needed. So, installation space, cost, operating systems upgrades, updates, etc. are reduced. Number 2, development of an information linkage program is not needed. Lastly, number 3, network load generated by event transmission is reduced and data collection omissions are eliminated. To this point, when using a traditional gateway computer, constant monitoring of PLCs and polling processing is necessary. But when an MES interface module is used, network load is reduced because events are transmitted from the PLC. Next, an application example showing how an MES interface module can be used. In this example, the production order already exists in a customer's database. This order contains key information on what and how many of a particular product they need to manufacture. To begin the manufacturing process, the operator will enter the order number into the HMI. The MES interface module will then reach out to the database and pull production data based on the provided order number. The production data for that unique order will then be used by the PLC to produce the requested product. During and after the manufacturing process, the MES interface module will then send data back to the database. This can be anything from order status, serial batch numbers, final weight, etc. At that time, administrators, management, customer service, etc. can check production or any other data they may require. The system can also be configured to allow administrators to specify the order number and start production remotely. This is useful when entering or leaving the site is not desirable, such as for semiconductors, pharmaceuticals, etc. Another key benefit of the MES module is that customers can eliminate the time-consuming process of manually collecting and recording production data. This automatically collected data can then be readily accessible and easily utilized by advanced analytics, visualization screens, or simply to generate real-time reports. Mitsubishi Electric offers a lineup of MES interface modules and GOT 2000 MES interface functions. You can select the models according to your scale. Mitsubishi Electric also offers products like SoftGOT to easily create intuitive screens. These screens allow you to visualize your data and can be customized to fit your application's needs. In this way, by using Mitsubishi Electric's MES interface modules, PLCs can be connected to databases without a computer, and data can be collected from production site and IT layer. Next, we'll show another example of how data can be shared between a MES interface module and a database to provide a unique serial number and lot sizes, as well as provide final inspection to ensure no errors occurred. Part 2, System Configuration and Introduction Procedure. In this section, we'll give an example scenario and hardware list for a production line that creates a small metal part. In the upcoming sections, we'll then take this example and show how you would configure the server and MES interface module. In this example scenario, the metal part manufacturing line consists of 3 steps. First, processing of the piece of metal. By the end of this stage, the metal part is formed and polished. Second, the engraving process, in which a unique lot ID and serial number are engraved on the surface of each manufactured part. And lastly, the inspection process, in which we verify the part is mechanically within tolerance and various data is recorded for future reference. The data flow for the three processes will be broadly divided into three parts. The first part is where the MES Interface Module obtains the manufacturing quantity from the production control database before the start of the manufacturing. The manufacturing process is then started, the requested quantity of metal pieces are formed, and the unique lot ID and serial numbers are engraved on each part. In the second part, each part is sent through the inspection process. Data such as the serial numbers, time of manufacture, part weight, etc. are collected by the MES Interface Module. The last part is the conversion of any needed data from the PLC. The MES Interface Module has the ability to convert units or apply arithmetic functions as needed. From here, the data can be sent up to the production control database to be used for shipping details, advanced analytics, visualization, and/or real-time reporting. Up next, we'll talk about the hardware used in this example scenario. In this example, the following pieces of hardware were used: Mitsubishi Electric's PLC IQR Power Supply Module, R61P, CPU Module, R120 CPU, MES Interface Module, RD81 MES 96N, SD card, NZ1 MEM-16 GB SD, a configuration computer, a server, and Ethernet cables. Please note that it's necessary to install the tools in the respective computers, install the MES Interface Function Configuration tool on the configuration computer, and install the DB Database Connection Service and DB Connection Service Setting tool on the servers. All of these tools can be installed from the MES Interface-R software. For the PLC program, please use MELSEC GXWorks 3. For information on the operating environments and system configuration caution items for each tool, please refer to the manuals. In the next two sections, we'll review the following procedures. 1. Start up the servers. 2. Start up the MES Interface Module and configuration computer. Up first, we have how to start up and configure the server. Part 3. Setup and configuration of the server. There are two types of servers: database servers and application servers. In this video, a database server, access type connection via service, will be used. Step 1. Create tables in the relational database. A relational database is a form type database like the Microsoft Access database used in this video. First, install the relational database, Microsoft Access. After installation has been completed, reboot the server. Step 2. Create tables. Tables are necessary for reading and writing data from to the database. Next, create two types of tables using Microsoft Access. The table name can be set as desired, but here, order table and history will be used. Launch Access from the Windows Start menu. In this video, Microsoft Access 2013 32-bit was used. Double-click the blank desktop database and input sample_db.accdb for file name. Click Create. Right-click Table, then click Table 1 and select Design View. Input Order Table for the table name. Click OK. Set the items in the Order Table tab and General tab as shown here. In the File tab, select Save. Right-click Table, then click Order Table and select Open. Set the items in the Order Table tab as shown here. This creates a table for production schedule data. This completes the creation of the Order Table table. Next, create a history table. In the Create tab, click Table. Right-click Table, then click Table 1 and select Design View. Input history for the table name. Click OK. Set the items in the History tab and General tab as shown here. This creates the production data table for collecting data for the MES Interface module. This completes the creation of the History table. In the File tab, select Save. This completes creating tables in the relational database. Step 3. Setting for the ODBC interface software offered by Windows will be configured. When using the DB connection service in the database server, it is necessary to perform the ODBC settings for the database in advance. Launch the ODBC Data Source Administrator. In the command prompt window, input the command corresponding to the MES Interface -R version and DB connection service bit version to be used. In this video, since Microsoft Access 32-bit will be installed, input the following command. Select the System DSN tab and click the Add button. Select Microsoft Access Driver and click the Finish button. Input sample for the data source name and click the Selection button in the database. Select sample_db.accdb in database name and click OK. Select None in System Database and click OK. Click OK on the ODBC Data Source Administrator screen. This completes the ODBC settings. Step 4. Install the DB Connection Service and DB Connection Service Setting tool from MES Interface -R on the server. Double-click setup.exe in the MES Interface -R DVD-ROM. The installer will launch. Select DB Connection Service and Setting Tool version 2 and 32-bit, and click the Install button. Follow the instructions on the screen and enter or select the necessary information. This completes the installation. Step 5. The Windows firewall settings will be configured. If the firewall function of the OS or security software is enabled, either set an exemption for the tools to be used in settings or disable the firewall function. This completes the server setup settings. Part 4. Startup and configuration of the MES Interface module. In this section, we will discuss how to configure your MES Interface module to communicate with the server. Before starting this section, please ensure your server is running. First, physically mount the MES Interface module to your backplane. Open the slot cover and set the dot matrix LED display mode selector switch to the right side. Next, launch GXWorks 3 on the configuration computer. create a new project. Select Project in the menu and select Create New. Select the series, type, and programming language, and click OK. Select if the module label and sample comment will be enabled or disabled, and click the OK button. To display the Add New Module screen, select Navigation window, then Parameter, and in the menu that appears, right-click on Module Information and select Add New Module. In the Add New Module screen, select Information Module for the module type and RD81 MES 96N for the module name. Set whether use of the module label and sample comment will be enabled or disabled. Click OK. Up next, we'll set the module parameter for the MES Interface module. To begin, select Navigation window, then Parameter, and in the menu that appears, right-click on Module Information and select RD81 MES 96N as a target module. Next, create a simulation program. For details, please refer to the manual. Use the engineering tool to write the parameters and program which were set to the CPU module. The settings will become effective when the CPU modules restart or its power is switched off and then back on. This completes the parameter setting for the CPU module and MES Interface module. Next, install the MES Interface Function Configuration tool on the configuration computer. Follow the instructions on the computer and enter or select the necessary information. Perform Windows firewall settings in the same way as when starting up the server. Select other confirmation items as necessary. This completes the installation of the MES Interface Function Configuration tool. Next, connect the MES Interface module and configuration computer. Connect the Ethernet port, CH1, of the MES Interface module and the configuration computer using an Ethernet cable. CH2 is not compatible with direct connection to a computer, so it cannot be used for a connection here. Insert the SD memory card into the MES Interface module. Launch the MES Interface Function Configuration tool. In the Windows Start menu, click MELSOFT, then MES Interface, and then MELSEC IQR Series MES Interface Function Configuration tool. In Specify Connection Destination of Online in the menu bar, set Direct Connection. For user authentication, specify the default username and password for the MES Interface module. When using an SD memory card that was used for other applications, be sure to format it using the MES Interface Function Configuration tool. Next, the network settings for the MES Interface module will be performed. In the Edit Item tree, select Network Settings. The default settings will be used in this example. Write the settings to the MES Interface module. In the menu bar, click Online, then write to MES Interface module. This completes writing the settings to the MES Interface module. Next, the parameter settings for the MES Interface module will be set using the MES Interface Function Configuration tool. Along with performing network settings, connect the MES Interface module, server, and connection computer to the network. In this video, the IP addresses of the server will be set to 192.168.3.200, and the IP address of the configuration computer will be set to 192.168.3.100. Continue by setting the connection route for the access destination devices. In the Edit Item tree, select Target Device Settings. The default settings will be used for this example. Set the device tags. In the Edit Item tree, right-click on Device Tag Setting and select Add Item. Input Getting Data for the device tag name and set each item as shown here. Add one more device tag. In the Edit Item tree, right-click on Device Tag Settings and select Add Item. Input Putting Data for the device tag name and select each item as shown here. Set the access destination server. In the Edit Item tree, right-click on Target Server Settings and select Add Item. Input Sample Server for the target server name and set each item as shown here. Set the access table procedure. In the Edit Item tree, right-click on Access Table/Procedure Settings and select Add Item. Input Get Plan for the Access Table-Procedure name. Set the Access Table-Procedure settings. Select Sample Server as the target server in Access Table/Procedure settings, and select Access Table as the table/procedure type. Set the DB table name. Click the Browse DB Table Information button in the Access Table Detailed settings. The table set in Microsoft Access will be shown in the DB tables. Select Order Table and click OK. Set the DB field information. Click the Browse DB Field Information button in the Access Table Detailed settings. Select Order Code, Product Code, and Plan Number, and click the OK button. Set each item as seen here, and click the OK button. Add one more access table/procedure. In the Edit Item tree, right-click on Access Table/Procedure Settings and select Add Item. Input Insert Data for the Access Table/Procedure name. Set the Access Table/Procedure settings. Select the sample server as the target server in Access Table/Procedure settings, and select Access Table as the table/procedure type. Set the DB table name. Click the Browse DB Table Information button in the Access Table Detailed settings. Select History and click the OK button. Set the DB field information. Click the Browse DB Field Information button in the Access Table Detailed settings. Select Serial Code, Date_Time, and Weight_kg, and click the OK button. Set each item as shown here, and click the OK button. This completes the linking of the Microsoft Access settings with the MES Interface module. Next, the job, or in other words, the work to be executed by the MES Interface module itself, will be set. Set the variables to be used in the job. In the Edit Item tree, select Variable Settings. In the Local Variables tab, set the variables as shown here and click the OK button. Set the job. In the Edit Items tree, right-click on Job Settings and select Add Item. Input Getting Plan for the job name. Select the main configuration in Job Configuration of the Select Job configuration and click the Next button. Set each item as shown here and click the Edit button. Set each item as shown here and click the OK button. Click the Next button. Set each item as shown here and click the Edit button. Click the DB Communication Action button in Action Type Selection. Set the DB Communication Action settings. Select Select in DB Communication Type of DB Communication Action settings, and select Get Plan.Sample Server in Access Table. Set each item in the Data Assignment tab and Narrowing Down Conditions tab as shown here, and click OK. Click the Next button. Select each item as shown here and click the OK button. Set one more job. In the Edit Item tree, right-click on Job Settings and select Add Item. Input recording for the job name. Select Main Configuration in Job Configuration section of Job Configuration and click the Next button. Set each item as shown here and click the Edit button. Set each item as shown here and click the OK button. Int 1 of the comparison target is set in the Integer Type Constant Setting screen. Select Comparison Target, then Constant, then Integer. Click the Next button. Set each item as shown here and click the Next button. Set each item as shown here and click the Edit button. Click the Operation Action button in Action Type Selection. Set the algorithmic action as shown here in order to divide the product weight in grams used by the PLC by 1,000 to convert it to kilograms, and click the OK button. Add one more action. After selecting the second row in the action list, click the Edit button. Click the DB Communication Action button in Action Type Selection. Set the DB Communication Action settings. Select Insert in DB Communication Type of DB Communication Action settings, and select Insert Data.Sample Server in Access Table. Set each item in the Data Assignment tab as shown here, and click the OK button. Click the Next button. Set each item as shown here, and click the OK button. This completes the settings to the MES Interface module. Part 5, Operation Check. In this section, we'll confirm data can be sent from the PLC to the database. Our first step is to write the parameters to the MES Interface module. In order to change from direct connection to connection via hub, it's necessary to change the connection priority setting in the MES Interface Function Configuration tool. Select Specify Connection Destination from Online of the MES Interface Function Configuration tool. Select Connection via Hub from the Connection Destination Settings pull-down list. Input the default settings for the user authentication settings. Write the parameters which were set using the MES Interface Function Configuration tool to the MES Interface module. To do this, select Write to MES Interface Module under the online menu of MES Interface Function Configuration tool. This completes the writing of parameters to the MES Interface module. After writing, reset the CPU module and start up the MES Interface module. After resetting, set the MES module to run status. Input the order code and read the manufacturing quantity from the database. After the CPU module has entered the run status, according to the simulation program written to the PLC, 2 will be set for the order number. Finally, the results that were written to the database table will be checked. In Access 2013, select Open, and then open the sample_db.accdb file. Right-click Table, select History, and select Open. The results, inserted into the History table by the MES Interface module, can be checked. The above is a procedure for inserting PLC manufacturing information into the server database. In addition, by introducing a production control application and connecting it to the database, exchange of the data between the production control system and the PLC becomes possible. Thank you for viewing this video. As always, if you have any questions or need additional assistance, please reach out to your local Mitsubishi electric representative. Have a great day.